Hello class, this is CSE-5720, Section 2, Week 15, Fall 2025. I'm going to be recording this video on my laptop rather than my main computer because that is the computer on which I have PG Admin installed. Before we get to that, let's look quickly at the homework solutions for Homework 3. So, Homework 3, you are given 4 queries from Homework 2, and you were to convert them into an equivalent set of relational algebra expressions. So, part A, find the names of all students who have taken at least one computer science course. So, the relations we need for that are going to be, let's start with takes and course. So, the takes relation is just a listing of all students by ID and the courses they have ever taken. But what we want are computer science courses. So what we could do, a naive way to do that is to find course IDs that contain the substring CS. That is one way to do it, but that is a naive implementation. It's possible that we might accidentally grab the wrong class. So there might be another class that has CS as part of it, but it could be a substring for some other course ID. So a more robust way to do that is to find all the course IDs that are in the computer science department. So the course relation is a listing of all courses by ID, but also says what department those courses are for. So what we need to do is do a natural join between takes and course. But that's not enough. What we want to do is filter out all the courses that are in the computer science department. So what we're going to do is do sigma department name equals computer science, of course. So that is all the computer science courses. We're going to natural join that with takes. So when we do that, that's just going to pair all the students who have taken a computer science course with the actual computer science courses. So if someone took a class that isn't computer science and we try to natural join that with a computer science course, it's just not going to be paired at all, and that is not going to be part of the final natural join. So what this does is it's gonna that subquery here takes natural join sigma department name equals computer science course. That is gonna be all the courses, all students who have ever taken a computer science course. But we want to find the students' names. So we're going to natural join the result of that with student. So much like before, it's going to pair all student IDs with their names. But we want the students' names, so we can just project the result of that and just get the names of the students. So that is the result of part A. Part B is find the names of all students who have never taken a computer science course. So let's step back. If we did just pi name of student, that just gets us the names of all students. What we want to do is this. Find the names of all students who have never taken a computer science course. So we can just find the names of all students and then remove the names of all students who have taken a computer science course. That leaves us with the names of all students who have never taken a computer science course. So we can have this query here, but do a set difference with the set of all students who have taken at least one computer science course. So since we can use the assignment operation to say A equals this expression here, we could just simply say B equals pi subname of student minus A. Or alternatively, we can just expand it like that. So that is answer for B. That's the answer for B. Part C, it's going to be a little bit tricky because we are using an aggregation operation and I could not get it to format correctly here. So for each department, find the max salary of instructors for that department. So what we need to do is group by department name and then find the maximum salary of each group. So this query here is nearly the whole answer. We just have to swap average for max and then we get this query here. So I could not get it to format it correctly. This G should be between department name and max salary. So that should be, so apart from that discrepancy, that is the solution for part C. Let's call it C. Part D, across all departments' maximum salaries, find the lowest of those maximums. So what we can do is find the minimum of all the maximum salaries. So what I can do is say G min max salary of all the max salaries. And we already have the max salaries up here. So let's call that C, assign it this query, and do D equals G min max salary of C. Again, we can just expand it to be this, and that also works. What could also work is aliasing max salary, so it's not max of salary, but rather max underscore salary. That also works. That way, when we do G min max salary, it's min of max underscore salary. That is an optional thing we can do, and in some notations, you're allowed to do that. Also, in some notations, it's not calligraphic G, but rather gamma. Again, that's just alternate notation for basically the same thing. So yeah, that's the solutions for homework 3 right there. Now we can get to work with getting started on your final project. So here I have PG Admin already opened. If it prompts you to enter your master password for PG Admin, do so at this point. What I'm going to do is create a simple database where I have 2 tables. The first one is a table of Magic the Gathering cards, and the second one is a table of Magic the Gathering sets. This is a very, very bare bones database, and depending on what you want for your enterprise, you might want it to be more robust, or you might want it to represent more information than just names of cards and names of sets. But this is a good starting point for what your database might require. Or you might expand this database so it's not just Magic the Gathering cards, but it could be cards for any trading card game. Say, uh, Pokemon, or Lorcana, or Yu-Gi-Oh! So, let's get started by creating the two tables that I wanted to make. A table of cards and a table of sets, specifically for Magic the Gathering. So, let's begin. Expand servers and then go to databases. What I'm going to do is right-click databases, click create database. I'm going to call it MTG database, and everything else can be left as the default values. I'll, I'll click save, and there we go. Now we have a Magic the Gathering database. Expand that, click schemas, click tables, and you'll see there's no tables. What I'm going to do is click create table. I'm going to call this one set. Then I'm going to go to columns and add 2 attributes. Well, 2 columns. The first one is set. The first one is name, and that's the primary key. The next one is abbrev, and that is an abbreviation for the same name. So I'm gonna then assign data types for this, and they're gonna be text and also text. If you have varchar, use that instead, but I could not find it here, so I'm just gonna use varchar. And then constraints. I want these to be unique, so I'm gonna add column name. Name should be unique. And then add another constraint, define column abbreviation to also be unique. So all set names and all set abbreviations must be unique. So those what those constraints are for. The primary key is the set name, and with the uniqueness constraints added, I think I'm good to, let me just name these. Name unique and abbrev unique. There we go. So names are unique and abbreviations are unique. There we go. So those are the constraints I'm going to add to make those are the constraints I'm going to add because I need that uniqueness constraint for the foreign keys for my next table. So I'm going to click save, and now I have the first of two tables. I'm going to click right click tables, click create table. Again, I'm going to call this card. I'm going to add 4 columns to this. The first one is name, and that's also a primary key. I'm going to add set abbreviation, and that's also a primary key. So the same card can be printed in more than one set. If, in this case, I want to differentiate between Soul Ring from one set and Soul Ring in a different set. Therefore, I need 2 primary key attributes for this, so name and set abbreviation. Let's also add another attribute that is rarity, and one more that is cost. Let's assign the appropriate data types for this. Text, rarity is text also, and cost, let's say it's numeric. Okay. Let's go to constraints because we have a foreign key constraint. We can only add cards if they exist in a particular set. Soul Ring exists in multiple sets. So let's add a foreign key constraint here. Constraints, go to constraints, foreign key. I'm going to click the big plus up there. Columns, local column, set abbreviation, references the set table, and it references the abbreviation column. Add. So I'm going to say set abbreviation FK for foreign key. There we go. So if I click save, there we go. Now we have 2 tables, that is a table of card sets and a table of cards. Now I'm going to click edit. No. Tools, query tool. And for fun, I'm just going to type in select star from set and click the play button up here. It worked. All right, what did it mean so far? So far, we just made the tables. Now we need to make, we made the tables. Now we need to make entries into those tables. So that was to make sure that our tables were working. I'm gonna do the same thing for card. So I just queried the set table and there's nothing in it. I'm gonna query the card table and there's also nothing in it. Here's what I'm gonna do first. I am gonna try to add Soul Ring and the rarity of Soul Ring ranges from uncommon to common, but okay, what I'm gonna do is I'm gonna try to add Soul Ring, and I want to be as accurate as possible, so I'm just gonna try this. Insert into card, and I'm gonna list out all the attributes for this. So if I expand card and then expand columns, see all the attributes here? Those are my columns. So I'm gonna add name, set, abbreviation, rarity, and cost. By the way, if you named your table using any characters that isn't lowercase or underscores, you need to enclose the name of your table in double quotes. That's not the case here, so I can just write it like that. Insert into card, name, set abbreviation, rarity, and cost, values. Now I'm gonna try to enter Soul Ring. So I'm gonna try to add Soul Ring from Modern Horizons 3. That appears to be an uncommon, so I'm gonna type Soul Ring in single quotes, set abbreviation is MH3, rarity is uncommon, and cost is $1.40. Let's try to add that. It did not work because the key MH3 is not present in the table set. There is no corresponding set MH3 because I didn't add it yet. Okay, let's go ahead and add that now. I'm gonna write another query below this. Insert into set. And the set attributes are, if I go expand this, columns, it's name and abbreviation. So name, abbreviation, values, and then I'm gonna type in Modern Horizons 3 and the abbreviation MH3. I'm gonna cut this query out of the way. Cut. Press play. Okay, query returned successfully in 43 milliseconds. Now I have that query cut out of the way. Now I can move that query out of the way, and I can try that previous query where I tried to add Soul Ring from Modern Horizons 3. By the way, you can also click Query History and you can see all the queries you've ever made. Now let's click play again, and look, it worked! Alright, let's now do select star from card, click play, there we go, now we have Soul Ring. Now if I do select star from set, now I have Modern Horizons 3. Let's add another set that is, let's add another card. So let's insert another set. So I'm just gonna copy this query here, paste it into here. I'm gonna add Doctor Who. Doctor Who, WHO. Add. Okay, oops, that was the wrong name. Let's try that again. And yeah, this was actually from a previous attempt to do this assignment where I had given the attributes different names. Okay, click play, insert it into the set table. So if I do select star from set and click play again, now I have Modern Horizons 3 and Doctor Who, both of them. Let's do another query. So if I click query history, insert into card, copy that, change the rarity from, hold on. Okay, let's keep going. Insert into card, name, set abbreviation, rarity, and cost. This time it's going to be the Soul Ring from Doctor Who. If I click play, it worked again. So now let's do select star from card to make sure that we have added that card. Soul Ring, Modern Horizons 3, and Soul Ring from Doctor Who. Let's pick out another card from Modern Horizons 3 just to flesh things out. Let's go with Electrozoa, and that one appears to be a common card. Let's go to query history and look at all the cards I've entered so far. I'm just going to copy that, paste into here, insert into card, MH3, and the name of the card is Electrozoa. Let's look at the cost of that. It is like 3 cents. So I'm gonna replace that with 0.03 to denote the cost. This is a common card, Electrozoa MH3, common 0.03. Play, and query returned, and let's make sure we have that card in here again. Let's see. Let's do select star from Click play, and there we go. We have 3 different cards in our database. Okay. Okay, so that's the basic gist of entering data into your database. So that is part 2 of your final. Part 3, you are going to do at least 3 different queries where at least one of those queries is a join operation, such as natural join. I'll leave it for you to work on that on your own. But for part 4, you are to make a backup of your database. What I'm going to do first is I'm going to save everything so far. I'm going to press Control. Okay, so. Okay, let's save the database. So. Okay, first I'm going to save that, and I want to make a backup of the database I have. So what I'm going to do is this. I am going to go to my Magic the Gathering database and right click backup. Let's go to general and enter the name of this. Let's call it MTG database dump. Set the format to plain. That way your backup file text is going to be plain text. Under data, select pre-data, data, and post data. This is something specific to this particular version of PG Admin 4, which is, I believe it's version 9.6. Yeah, 9.6. You want to select pre-data. If you do, it will write the necessary queries to create all the tables. Okay, so make sure all that is selected. We don't have to turn on blobs unless you are working with blobs here. Okay, that's data options. Then go to query options and select the following. Use insert commands, and for completeness, include create database statement. Under table options, use column inserts. And then once we have all those options selected, let's make a backup. Also, I am going to save this into the same folder as the lab database example here. So keep note of where you are saving this backup file. I think I'm just going to save it to desktop. It's going to be a little bit easier to find that way. Let's call it MTG database dump. It's going to save the desktop and click backup. Okay. Now, let's go to this database file. It's a .sql file. Let's open up with Visual Studio Code. What I want to see is the queries necessary to create the tables and the necessary queries to populate the tables. If we have those, hey, we have create card, create set, and then we have the queries needed to populate the tables. And here too. Okay, perfect. So this is okay, so there were some constraints added as well. Make sure those constraints are there. Okay, so this is a dump file. This is a backup file of your entire database. So this is what you are to submit. You're also submitting a few screenshots as well. So part 1 does not require any screenshots at all. So let me just pull up the instructions. So part 1 was just making the tables necessary for your database. You do not need to take any screenshots at all. In fact, evidence of you making the tables can be seen as part of your SQL file. Part 2, a screenshot of data being added to each table. So you just take a screenshot of some of the queries. So for each table, take at least one screenshot of data being added. That's part 2. Part 3, screenshot the 3 queries that you're going to do and the results. And part 4, it's the SQL file. So part 1, the evidence of you doing part 1 will just be part of your SQL file. If you have the SQL file and it contains the create table commands, those are evidence of you making your tables. So just by doing part 4, you already do part 1. Okay, so yeah, now we have a backup of our database, and that is what you're going to be submitting alongside your screenshots. Another thing, if you are more familiar with a different program than PG Admin, I suggest you use that. Just make sure to make a backup of your database in the format that I specified, where you have. Make sure your backup contains create table commands here and insert into commands as well. So as long as your .sql file has create table and insert into, you are good to go. All right. So that's the instructions for the final and the solutions for homework 3. All right. I hope you've had a great time following along with databases. And with that, there's still the matter of your last video to be put out, but I'm gonna put that out this weekend. I said it was chapter 9 and 10, but I actually misspoke. It's actually gonna be chapters 10 and 11 and 12. But chapter 10, a lot of it is just review from operating systems, so I'm not gonna cover a lot about chapter 10. But I might talk about a little bit about chapters 11 and 12. So yeah, that's gonna be the last thing I'm ever gonna talk about for databases. And with that, I think we can conclude the course here. All right. Thank you for sticking throughout the whole semester. And with that, I'm going to post the final video on chapters 10 and 11 and 12 this weekend. All right. Good luck on the final and have a good one.